Okay, good morning, class. So today we're looking at Euclidean geometry. We're looking at the examples for exercise 9.4. 5, sorry. So at this point we have just proven the theorem that says, firstly we read through the points of a cyclic quad. Then we prove theorem 5a. The theorem that says that opposite angles in the cyclic quad is supplementary. The link to this proof can be found in the description box below. Okay? So we went on and we proved this and we made our notes. Our notes, we said that if you got given a circle and the 4 points are touching the circumference of the circle, if 4 points touch the circumference of the circle, we said the quad is said to be cyclic. Okay? Amber, leave the tuck shop orders now. You look here now. Huh? So the 4 points are touching the circumference of the circle. If that is the case, then angle Q plus angle S is equal to 180. Why? Opposite angles of cyclic quad. Or angle P plus angle R is 180. Why? Opposite angles of cyclic quad. Supplementary. Yeah? Then the converse is true. And what did we say the converse is? The opposite or the reverse. In the converse theorem to this, we are told that, and we spoke about this already, is that if you got a quad, what's a quad? A enclosed four-sided figure. Four-sided figure. If angle P plus angle R was 180, okay, I meant to have changed the letters. But okay, if angle P plus angle R is 180, then it is said that PQRS is a cyclic quad. Why? Opposite angles is supplementary. Or we said you can use what? Converse of opposite angles of a cyclic quad. Okay, either or. Right. Then we spoke about the exterior angle of the cyclic quad. We managed to prove that D1 is equal to angle A. So later on we can just say D1 is equal to AY. Exterior angle of cyclic quad equals the interior opposite angle. And the converse is also true. Okay. So they speak about all of that. This is the one that I said is the converse. Is that if the exterior angle of a quadrilateral is equal to the interior opposite angle, then the quadrilateral is cyclic. If B1 is equal to D, then ABCD is a cyclic quadrilateral. The reason for the theorem, exterior angle is equal to the interior opposite. People, if the question says, prove that it's a cyclic quad, we can't use in our reason cyclic quad. Okay? We can't, because we are proving it. Unless you say the converse of cyclic quad. Okay? And you'll see me highlighting that in this example as well. Later on. Okay? So now we're looking at the example 1, which is on page. Example 1 is on page 299. So here we are told that in the accompanying diagram, so the diagram alongside, AX and YB, so AX and YB are chords that are produced to D and E respectively. Respectively means in that order. Such that DC is parallel to AB. People, if these lines are parallel, what do we know? We know that alternate angles are equal, corresponding angles are equal, and 20 is supplementary. What do we know? That angle C is equal to angle D1. Why? Corresponding angles. We might need it or might not. Also, co-interior can be applied and so on. Okay. Such that, okay, then we are told that XY is drawn. XY is drawn. Prove that D, C, X, sorry, D, C, Y, X. It's a cyclic quad. Okay, and this is an often asked type question. Okay, to prove something is a cyclic quadrilateral. People, there are three ways you can prove something is cyclic. 3 ways. What are the 3 ways? Firstly, the butterfly, angles, the converse of angles in the same segment, or opposite angles are supplementary, not equal, which means to say they add up to 180, or exterior angles equal to the interior opposite. Any one of these 3. Okay, so make a note there. When we're proving cyclic quadrilaterals, when we're proving that the quadrilateral is cyclic, we prove one of these 3. Okay, so now you must write this down like that. Again, to prove something is cyclic, Zara, come on, Michael. Prove something is cyclic, you either prove the converse of angles in the same segment, or the converse of opposite angles of a cyclic quad is supplementary, or the converse of exterior angle of cyclic quad is equal to the interior opposite. Or you can use the other reason, which is equal chords obtains equal angles on the same side, or equal arcs obtain equal, right? In this one's going to be opposite angles are supplementary, or this one's going to be exterior angles equal to the interior opposite. If you don't want to use the word converse. Okay. So which one of the 3 you think we're going to use here? The first one. Where do you see angles in the same segment? There's no diagonals here. The second one, which is opposite angle supplementary. You don't have this angle. But what do we know about B1? Is it B1 the same as X1? Can you see here? So the exterior angle is equal to the interior opposite. We are moving too fast here. Yes, okay, let me just go a bit slower. So it's off. So again, the question says, we must prove that BCYX is a cyclic quadrilateral. Okay, how do we prove cyclic quadrilaterals? One of 3 cases. The bow tie, or opposite angles are supplementary, or exterior angles equal to the interior opposite. One of those 3. Okay. So they told us that these lines are parallel. Not so. So if you look at the quad, where do you see an exterior angle here? X. So if we can prove that x1 is equal to c, we've done the job. Not so. So we start off by, you say, let angle C1 equal angle C1 equals x. So if angle C1 equals x, which other angles equal to x? B1. And why is angle B1 x? Angles in the same segment. Why is it corresponding? So x1 is equal to b1. Angles in the same segment. Yes. So x1 and b1. Oh, sorry. Well, that's why she's saying corresponding. I was wondering why she's saying corresponding. What's wrong with that? Sorry, no? So you say let x1 equals x. Sorry. Right. So if x1 is equal to x, then b1 is equal to x. Why? So angle b1 is equal to x. Angles in same segment. And it's coming from arc A1. You have to mention this arc here? No. Okay. Now what? Corresponding. There is a corresponding now coming. Okay. So angle C is equal to x. Why? Corresponding angles with DC being parallel to AB. So have we managed to prove it? Yes. You see that? So this is how we conclude this question. We state the obvious, We say since angle C is equal to x1, which is equal to, since that is the case, can you see that? Since that is the case, therefore, you answer the question, therefore DCYX is a cyclic quad. Why? Because the exterior angle equals the interior opposite. Okay. Or we could have written converse of exterior angle of cyclic quad. Okay. Any confusion? Any questions? Something like this probably worth 4 marks. Okay. The full lesson can be found in the description box below. Let's look at example 2. Example 2, we are told that, is it still on page 299? In the diagram, POQ is the diameter. People, if POQ is the diameter, what can we conclude? R2 and 3 is 90. Why? Angle in semicircle. Then they ask you, chord SR is drawn parallel to PQ. People, if these lines are parallel, what do we know? P1 is equal to? Oh, there, the lines are parallel, alternate angles are equal. But why? Because they told us these lines are parallel. You see that, people? Then we are told that OR and PR are drawn. R1 is 24, calculate the size of O1. So we know that angle at center is twice angle at circumference. Can you see that? So if I got P1, I know what O1 is. So that job is done basically. Not so. You see how easy the stuff is. I can't help it. No? I'm trying to get you nice challenging ones. So firstly, again, you're not going to go straight. So firstly, P1 is 24. It's equal to 24 degrees. So alternate angles with PQ parallel to RS. Okay, I'm just going to move this down. So we say P1 is equal to 24 degrees. Alternate angles with RS being parallel to Q. And then O1 is double 24, which is 48. Why? Angle at center is equal to 2 times angle at circumference. 48. Right, so that job is done. Let's look at B. We want you to work out angle Q. Angle Q, how can you work out angle Q? Angle Q is the same as P3. Angles opposite equal sides, then sum of triangles. Not so. How else could we have worked it out? Sorry? Sorry? Right, there's another way. This is straight line. And then angle at center is twice angle at circumference. Nice. It's another way. This was 90 degrees. I said it earlier on. So P or Q is equal to 90 degrees. Why? Angle in semicircle. Okay. And then angle Q is 180 minus 90 minus 24 degrees. Why? Sum of triangles. And this triangle PQR gives an angle of 66 degrees. Okay. You all agree with that? And the last one in this question is S. I'm going to calculate S. Yes? Come back to B, yes? Radii, yes, let us say first. You're going to go say that is equal. Angle Q is equal to R3 and then sum of triangles. I did say that one. Okay? Yes, you would have gotten full marks there as well. How are you going to calculate S?
So we calculate Q2 by
Q2.
Straight line. O2.
O2. Okay, and then?
Angles at twice angles at center is equal to.
So you got O2, then you say 360 minus, and I get that angle.
Yes.
Then angle at center is twice angle circumference. Nice. That will work, but it's an extra step. But still you'll get full marks. Yes?
Or calculate O2 and then do the opposite angles.
Of a cyclic quad. I like that. But what's the problem with it? She said calculate O2 and then we got opposite angles supplementing. This does not touch the circumference of the circle. So it's not going to work for us. But you're on the right track. That's the theorem I'm looking for. Angle Q, there we go. You see that cyclic quad there?
Yes.
So we can say that angle S is equal to 180 minus 66. Why? Opposite angles of cyclic quad. So angle S works out to be 144. Sorry, 140. Alright, let's just check here. Alright, so with that you should be able to, listen, settle down. So with that you should be able to do from exercise 9.5. You do for me number 1. 9.5 is number 1, 2, and 3. 1, 2, and 3. People enjoy the rest of your day. Good morning, class.